The first part of this session, we are going to draw a geometry of a pipe. Therefore, we double click on the geometry section to start the design modeler solver. The design modeler solver environment, in order to simply draw the geometry of a pipe, which is a cylinder, we click on create, go over primitives, and then select cylinder. After clicking on the cylinder option on the low left side of the software window, scroll down this window, and then in front of the axis Z component, you can enter the value for the length of your pipe. Also in front of the radius, you can define the radius of this cylinder. As you can see here, we have entered the value for the length of our pipe equal to 5 meters while letting the radius to be equal to 1 meter. Now that we have drawn the geometry of a pipe, we can simply exit and close the design modeler solver to start the ANSYS Meshing. Now for the first time that we open the ANSYS Meshing solver, we are going to try to create a structured mesh for this pipe. Therefore, we right click on mesh to create some local settings. Right clicking on the mesh, go over insert and then click on methods. After clicking on the method option on the low left side of the software window, you will see that a new part will appear. In this part, in front of the geometry, you can see that this section is colored in yellow, which is asking us to select a geometry or a body which we want to create this method option with. Simply select and click on our cylinder, and then in front of the geometry, we click on the apply button. Then in front of the method, select multi-zone option, which was explained in the previous sessions completely. And then simply click on generate mesh button. As you can see here, although the software has created hexagonal mesh over our geometry, but it couldn't create a structured mesh for it. Thus, in order to create a structured mesh for our geometry for the second effort, we are going to use some other local setting. Therefore, we suppress this multi-zone option. This time we are going to try to use the face meshing method so that we can create a structured mesh for the cross section of our pipe. Therefore, we right click on mesh, go over insert and select face meshing, as you can see here. After clicking on the face meshing option, again on the low left side of the software window in front of the geometry, this time select the cross section of your pipe or cylinder, as you can see here, and then click on the apply button. After selecting the cross section of the pipe as our geometry of interest, we right click on the mesh and then click on generate button to see whether the software is able to create a structured mesh for this surface. Well, as you can see in this slide, the software was not able to create a structured mesh for our geometry, and it even changed the mesh into tetrahedral. Therefore, the face meshing option was not what we were looking for. Therefore, for the third try, we're going to use another local setting. Now, for our final effort and try, we are going to use the sweep method option. Therefore, we right click on the mesh, go over insert, and again click on methods. Again, in front of the geometry, we have to select the body of our pipe. Then in front of the method, we change it from automatic to sweep method. Well, in this section, we don't need to change anything and any option because the software is intelligent enough to understand the right direction for the sweep method. Therefore, we right click on the mesh again and then click on generate mesh. Now, as you can see here, even with using the sweep method option, the software wasn't able to create a structured mesh for our geometry. It even returned with an error. Therefore, in order to create a structured mesh for the kind of geometries like this pipe, we need to make some changes in the geometry section. Therefore, we have to close the ANSYS Meshing software and return to the design modeler. Now, in the design modeler software, in order to be able to create a structured mesh for a pipe, for example, we have to create a cubic structure inside this pipe as well. To create such a structure, we click on the cross section or the surface of our pipe, and then we click on new sketch button. After creating the new sketch, click on the sketching button, as you can see here. Then under the draw section, click and select a rectangle and then draw a rectangle over the selected surface as you can see here. Next, go under the dimensions section and click on semi-automatic option. After selecting this option, if you go over the outline of your drawn rectangle, you will see that different dimensions will appear. After each dimension appeared, click and go to the next dimension. After all the dimensions were finished, go on the low left side of the software window and enter the values for each dimension as shown in the next slides. After entering all the shown dimensions, click on Extrude button. After clicking on the Extrude command on the low left side of the software window in front of the geometry, make sure that your drawn sketch is selected, and then in front of the operation, change it from Add Material to Slice Material. Now, because we want this cubic structure to have a length equal to the length of our pipe, we change the direction from normal to the surface. And as for our target face, we select the cross section of the pipe, which is shown in this slide. Next, after clicking on the Generate button, if you click in front of the two parts and two bodies and expand it, you will see that two different parts are present here. Now in this section, if you click on each of the two bodies shown here, you will see that it will become selected and shown in gold color. The first body referred to the pipe minus the cubic structure, and as I click on the second body, you will see that the cubic structure would become selected. Now, because we want to have these two bodies as a united body with the name of pipe, we right click on these two bodies when they are selected and then click on Form New Part. Now we can close the Design Builder software and start the ANSYS Meshing again. Now that we have created this cubic structure inside our pipe, we can simply use the sweep method to create a structured mesh for our geometry. Therefore, we simply delete the multi-zone option and then click on face meshing to complete this setting. As was previously mentioned, we need to complete the face meshing option. Therefore, we click on it and then on the low left side of the software window in front of the geometry, as you can see here, if we click on it, one of the faces of the cross section of the pipe would become selected, but we need to select both faces related to both the pipe and the cubic structure. So as you can see here, after selecting the face related to the pipe itself, we hold down the Control key and then select the face related to the cubic structure, and then we click on the play button in front of the geometry. For the next step, we need to complete the settings related to sweep method as well. After clicking on the sweep method option, the first thing that we should do is to select the correct geometries. Just like what we did for the face meshing option in front of the geometry, we have to select both the pipe body and the cubic structure. Now, if I click on the Generate Mesh button, you will see that a structured mesh would be generated over our pipe body. Now, as you can see here, in contrast to our three previous efforts, we have succeeded to create a structured mesh for our pipe. Therefore, you can easily learn that in order to create a structured mesh for geometries and structures like pipes, you have to first create a cubic structure inside them, and then using that cubic structure, you would be able to create a structured mesh for your geometry. It should also be pointed out that you can control the sizing of each element by simply adding a local sizing setting. To do that, we right click on Mesh, go over Insert, and then select Sizing. In order to, for example, increase the number of mesh cells that are placed over the edges of our cubic structure, we can simply select the Edge Selecting command first, and then select the edges of our structure. After selecting all the four edges, we click on the Apply button in front of the geometry. After clicking on the edge selecting command, hold down the control key and select all the 4 edges that you can see for the cubic structure. Next, in front of the type section, we changed it from element size to number of divisions, and as you all probably know, when we select the number of divisions, we can enter the number of mesh cells that we want to place over an edge, for example. As you can see here, for example, we have selected the number of mesh cells that we want to place over the edges of our cubic structure to be equal to 10. Now, if you compare the new mesh with the previous mesh, you can easily understand that the number of mesh cells placed inside our computational domain or the cross-section of the pipe that you can see in this slide has increased. It also should be mentioned that using this specific geometry that you can see here, we may not have a full control over the number of mesh cells, for example, over the cross-section of our pipe. In order to have a full control over the number of mesh cells that we want to place, for example, in the pipe section itself minus the cubic structure section, we have to divide our geometry into different sections using the slice command. Now, dividing any type of geometry to create a structured mesh would be explained for the next geometries. Again, if you are wondering how you have to divide the cross-section of this geometry in order to have full control over the number of mesh cells that you want to place radially for the pipe cross-section except the cubic structure section, you have to use the slice command and then slice your geometry in an X shape, as you can see here. Also, it should be pointed out that you have to only slice pipe's cross-section minus the cubic structure section, meaning that the cubic structure section would have to be intact and only the cross-section of the pipe should be divided into 4 different sections. Now, for our next geometry to create a structured mesh over, we are going to show you how you can create a structured O-grid mesh over in geometry. In order to replace a geometry, you can simply right click on it and then go over replace geometry and then select your geometry using the browse option. After replacing the geometry, we need to make some changes over it so that we can create a structured mesh for it. Specifically, what we're going to do next is to divide our geometry into 2 different sections and then create a structured mesh. What we're going to do is to divide our geometry into 2 different sections using the slice command. To perform such task, we need to use the slice command, as you can see here. After selecting this command, the software will ask us for a cutting plane. You have to click on YZ plane as you can see here, and then click on apply button in front of the base plane, and then click on generate button so that your slice command is performed. Now that our slice command is performed, as I click on the parts or body section, you can see that 2 different parts will appear here. Now we need to make these 2 parts as a united body. Therefore, we expand this section and then select these 2 bodies and then right click on them and select form new part. You can see these 2 parts become selected with gold color as I click on them. Now, by selecting both of the bodies and then clicking on form new part, as you can see here, these 2 bodies will become one body. Now that we have turned our 2 bodies into one united body, and we have also maintained the cut edges generated by using the slice command, we can close the designer software and start the ANSYS Meshing software and then use these cut edges to create a structured mesh. Now that we have imported our geometry into the ANSYS Meshing, in order to make the software understand that we want to create a structured mesh for this geometry, we are going to use the multi-zone method. Therefore, we right click on the mesh, go over insert and then select method. As you all probably know, after selecting the method option on the low left side of the software window, the software will ask us for the geometry of the interest. Therefore, in front of the geometry section, before clicking on apply button, we have to select our 2 bodies shown here while holding down the control key and then click on apply button. After selecting our two bodies in front of the method, we simply change it from automatic to multi-zone, and then we'll leave the rest of the settings to be on their default. Now, as I right click on the mesh and then click on generate mesh button, you will see that the O-grade structured mesh type will be generated over our geometry. Now, as you can see here, all the parts of our geometries have a structured mesh placed over them. You can also increase or decrease the number of mesh cells that you want to place over your geometry by simply selecting the sizing option. We do that by right clicking on the mesh and then going over insert and then selecting sizing. After selecting the sizing command, we go over the edge selecting button and then click on it so that we can select our edges generated using the slice command in the design mirror software, and then select them as our geometry of interest, which we want to put a different number of mesh cells over them. As you can see here, on the surface of our geometry, we are going to select only one of our edges because the whole surface of this geometry is continuous. Therefore, by only selecting one edge, we can simply define the number of mesh cells that we want to put over this surface without any problem. Therefore, after selecting the one edge, as you can see here, we click on apply button in front of the geometry, and then we change the type section, which is shown with the yellow color here, from element size to number of divisions. And then as for the number of mesh cells that we want to put over this edge, we select and enter, for example, the number of 10. Also, if you wish to control the number of mesh cells in the depth of your geometry, you can simply repeat the steps that we took in the previous slides, and this time select the edge of the geometry that is placed in the depth of your geometry. Again, because the inner surface of our geometry is continuous, it is enough to select only one edge. Therefore, we select it and then click on the apply button in front of the geometry. And again, we change the type section from element size to number of divisions. And this time, for example, for the number of mesh cells in the depth of our geometry, we select the number of 7. Now, if I click on the generate mesh button, you will see that the mesh cells that will be generated over our geometry will become more dense as we have increased the number of mesh cells over the top surface and the inner surface of our geometry. Now that we've shown you how to create O-grade type of a structured mesh over geometries like this, we are going to close the ANSYS Meshing software in order to open a geometry in which we have drawn an airfoil, and that we are going to show you how to create a structured mesh for those type of geometries. As you can see here, we again right click on the geometry, go over replace geometry section, and then select airfoil for meshing section. Now what you see here is a plain 3D geometry of an airfoil and its surrounding domain. Just like what we did for the previous geometries, and that we divided them into different parts in order to create a structured mesh, we need to do and repeat the previous steps here as well. Therefore, we first have to generate some planes, and then using these planes we are going to perform the slice command. Therefore, we click on new plane command, and then in front of the base plane we select YZ plane as the plane of interest. And then we click on generate button so that our plane is generated. We need to repeat these steps 2 more times so that we can have 3 different planes. Again, we click on new plane button. But this time, in contrast to the previous type plane, we change the type section from plane to point and normal. And then on the lower left side of the software window in front of the base point, we select one of the ending point of the airfoil, as you can see here, and then click on apply button. And then underneath it, in front of the normal defined by section, we select YZ plane and then click on apply button. Now by clicking on the generate button, our second plane would be generated. As for the third and final plane, we again click on new plane button. Now for this new plane, in front of the base plane, we select ZX plane and then click on generate button. Now that we have all the needed planes to divide our geometry into different sections, we simply start using the slice command. We simply first click on the slice command, and then in front of the base plane we select our three plane one by one. After performing the first slice using the first plane, we again click on slice command for the second time. As you can see here, as for the base plane here, we have selected the second plane. As for the final slice command, we perform the same previous steps, and then as for the base plane, we select the third plane. And finally, under the part section, just like what we did for the previous geometry, we select all the shown bodies and then right click on them and then select form new part to have one united body. Now that we've finished dividing our geometry into different sections to create a structured mesh over it, we close the Design Builder software to start the ANSYS Meshing. Now before proceeding to the section where we apply the local settings for this geometry, we change the physics reference section from mechanical to CFD, because what we're going to do next after meshing this geometry is to analyze our mesh cells in Fluent. Therefore we have to change it from mechanical physics preference to CFD. Again, in order to mesh this geometry, what we're going to use is the method option. Therefore we right click on the mesh, go over insert and then select method. As you all can probably remember, when we use and select the method option, the software will ask us for the geometry of interest. On the lower left side of the software window, in front of the geometry section, which is colored with yellow color, you can see that we have selected nobody. In order to select all the different bodies of this geometry, as you can see in the graphics window, we'll right click on a blank space in this section and then select all option, and then we click on the apply button in front of the geometry. The next thing that we are going to do is to change the method from automatic to multi-zone, and then we'll leave the rest of the settings unchanged. Now as I click on the generate mesh button, you will see that C grade structured type of mesh would be generated over our geometry. Now, as you all can probably guess right, what we are going to do next is to create some sizing option, specifically create some edge sizing option and select the edges of our airfoil to put and place a bigger and larger number of mesh cells over it, to have a better quality mesh cells placed over our airfoil, so that we can have a more exact and more correct analyze when we import this geometry or mesh into the Fluent software. Therefore, to access the sizing option, we right click on the mesh, go over insert and then select sizing. As was previously mentioned, we are going to select the edges of our airfoil. Therefore, we select the edge selecting command and select the edges of our airfoil, which are shown in the next slides. After selecting the upper and lower edges of our airfoil, as you can see in this slide, we click on apply button in front of the geometry, and then we change the type section from element size to number of divisions. And for example, in this section, we enter the number of divisions equal to 20. Also, we would like to increase the number of mesh cells that are placed in the front section of our airfoil. So we repeat the previous steps and enter a sizing command. After selecting the two edges that are placed in the front section of the airfoil, we click on apply button in front of the geometry, and then in front of the type we change it from element size to number of divisions again. And as for the number of mesh cells that we want to put here, we set the value of the number of divisions equal to 15. And now, as you can see here, after I clicked on the generate mesh button, the mesh cells that are placed on the top and bottom section of the airfoil have become more dense. However, you can still increase the number of the mesh cells placed over these edges so that you can have a better and more correct analyze in the Fluent software. Also, if you wish to control the number of mesh cells that are placed vertically on the upper and lower section of the airfoil, you can repeat the previous steps and create another edge sizing. However, this time the edges that you have to select are as follow. Now the edges that must be selected are shown in this and the next slides. After selecting all the 7 edges that you can see here, click on apply button in front of the geometry, and then change the type section from element size to number of divisions. And this time in front of the behavior, change it from soft to hard so that you can override any default setting that the software would apply itself manually. Now, as I click on the generate mesh button, you will see that the mesh cells that are placed over the selected edges in the previous slides would become larger, indicating that our override setting was applied. As you can see here, in contrast to the previous mesh type over the same geometry, which we had a smaller mesh cell near the front section of our airfoil, in this type of mesh where we have decreased the number of mesh cells over the selected edges, the size of each cell has increased. Also, another point that should be mentioned is that because our geometry was in 3D, as I zoom in the corner of our geometry, you can see that only one cell has been generated in the depth of our geometry. And for the final part of this session, we are going to show you how to create hybrid mesh over a geometry containing a solid and a fluid part. And now, just like we did for the previous geometries, we right click on the geometry section, go over replace section, and then select the hybrid mesh. Now, as I have opened the ANSYS Meshing software, you can easily see that the geometry that we wanted to perform the hybrid mesh on is a section of a pipe in which a solid section similar to the pipe geometry has been placed inside it. You can also define the fluid or the solid section from the ANSYS Meshing software as well. All you have to do is to expand the geometry section and then expand the part underneath it, then click on one part that is shown here. After clicking on one of the parts shown here, head down to the low left side of the software window in front of the fluid or solid section, and then change it from defined by geometry to fluid, for example, for this part. And then for the next part, which is the solid part, again click on it, and then in front of the fluid or solid section, change it to solid. As the ANSYS Meshing software is an intelligent software, without even applying any local setting to the mesh section here, it will understand that we want to perform a hybrid mesh over our geometry. Therefore, it puts a tetrahedral mesh cell for the fluid section while putting hexagonal structured mesh over the solid section. Now that our mesh is generated, in order to show you the interior of our mesh, we use the section plane command. Now, as you can easily see here, the fluid section has been filled with tetrahedral mesh cells, while the solid section has been filled with a structured hexagonal mesh. Also, in order to have a better view of the solid section where the software has applied the hexagonal structured mesh over, we are going to hide the fluid section, which is the outer section of the solid. As it is shown here, and you can probably understand, the mesh type that has been generated over the solid section is not a type of mapped mesh. However, it is hexagonal and structured. And for the final part of this session and in this section, we are going to teach you how to create boundary layer mesh over the solid section inside the fluid section. Thus, after unhiding the fluid section, we right click on the mesh, go over insert, and then select inflation option. After clicking on the inflation command, on the low left side of the software window in front of the geometry, you only have to select the fluid section because the boundary layer mesh would be created inside this region. After selecting the geometry, the next thing we should do is to select the boundaries over which we want to place boundary layer mesh. Therefore, before actually selecting the needed surfaces, we have to disable the section planes. And then for the boundary section, we are going to select the outer faces of the pipe or the fluid section without selecting the inlet or outlet of the pipe. Now, by only selecting these three faces, the software will only put the boundary layer mesh over the inner faces of the fluid section. Since we wanted to place the boundary layer over the solid section as well, what we are going to do is to hide the fluid section body. And now that we have access to the solid section, we again click on the boundary section, and then while holding down the control key, we select all the faces of the solid shown here. Now that all the surfaces that wanted to generate boundary layer mesh on were selected, we can simply click on the apply button in front of the boundary, and then we right click on the mesh, and then we simply click on generate button so that the software starts making and generating the boundary layer mesh inside our domain as well. Now for the next step, all you have to do is to show the hidden body, and then using the section plane command, we can understand what is going on in the interior of our mesh. Now, as you can see in this slide, not only have we created boundary layer mesh over the solid section, but we have also created the boundary layer mesh over the interior faces of the solid section.